what I have found over time is it usually seems people either really get this or they're just totally lost. But with a lot of people who think they're totally lost, I don't think they are. I think they just dwell on, I don't understand why we have to do this. All right, and as I mentioned to you before, this is the way that many programming languages are going today. Okay, because you end up that when you create objects, I should even say take it a step higher, when you create classes, you can basically mimic anything that happens in an organization. All right, so the you do it that starts on 370 and it goes for 4 pages, it says here, in this section, you create a student class. First thing to realize, I want you to understand this, is when you create classes, we're going to create literally a separate file. Class files, even if it's a GUI program, class files are code only. Class files have no GUI component. Did you all hear that? All right. It's really important to understand, but the first examples that they give in the book here are all non-GUI examples. So these are console examples. Now, I want to show you this because I didn't do it exactly the way that the author does it. The author says, type in this, then type in this, then type in all this stuff, then type in all this stuff, then go back to the top and add all this stuff. So the author wants main in the same file as the class, which is a bad idea. You don't typically do this. Why? Hopefully you remember one of the things that I told you a while back was that in an ideal world, main acts as a program driver. Main doesn't do the work. It calls the stuff to do the work. And again, sorry if I keep boring you with stories, but I maybe have said this to you or said it to you last semester. I'll always remember this. There was a guy, the boss that I respected probably the most out of any boss I've ever had in my life, Larry. When I was working at Black Hawk Technical College, I always wondered, he walked around all the time. He'd walk into classrooms, he'd talk to me, he'd talk to students, how's everybody doing? And I thought, what the hell does this guy do? I know he makes a hell of a lot more money than me, but what does he do? I had no clue. And then he left for a couple weeks. And all sorts of stuff that was getting done wasn't being done. He was really good at delegating authority. He knew who could do what. That's what main should be doing. So the way I did this, and I'm going to show you this again, you're going to get this code. Don't write it down. Don't worry about it. Nothing. But this is what I did. Whoops. I'll open up the wrong software, but that's fine. Make sure that this is the right one. Yes, it is. All right. So what they show in the book on pages 370, 371, the stuff that's on there is what I put into the one file. The stuff that they show on the top of page 372 and on 373, I put in another file. You don't have to do it that way, but that's the way you should learn. Why don't, again, why not teach you the right way to do it from the beginning? That's my philosophy, whether that's right or wrong. So let's take a look at what's in here. Okay. What we've always had in there basically is we've had class something, class program, and then we've had main underneath it. Okay? That's what we've done so far. This is, I accidentally opened up this software. Try to close it. Okay. There. All right. So this is the same stuff that's shown on the screen right here. Everything that is right here is all the stuff that is shown on steps 1 and 2 of page 370. Now, the only thing that I changed was I put the constants first and then the instance variables. That's the way most people do it. Constants and then variables. Do you have to do it that way? No. Does it work okay if you do it the other way? Yes. But this is the way most people do it. So, gee, Jeff, why didn't she show it that way? Don't have a clue. All right? So we've got right here we've got two constants. The highest GPA you can achieve is 4. The lowest GPA you can achieve is 0.
Now, just looking at that, at least ideally, that should make sense to all of you. All right? So, each time that we create a student, that student will have an ID number, they will have a last name, and they will have a grade point average. They kept it simple. They could have said name, and they could have made it first name and last name, or they could have had a first name, and they could have had a last name. They're just keeping this simple. So every time we create a new student, those students will have those three properties. Does that make sense? Yes? Technically, the students don't have a first name. They don't have a middle name. They don't have anything else. They only have what we give them. This is all we gave them. All right? So then afterwards, and this is what they show in step 3 on page 371. This is a getter, and all that does is it returns the ID number for the students. This is a setter, and it says whatever we set the student's ID number to, that's going to be their ID number. Then the same thing with the last name, and the same thing with the grade point average. Okay? Now, all of this code that you see here, all of this, every one of these get sets, okay? Since I'm not doing anything special with them, and you may or may not even know this exists, so if you all look up on the screen here, I'm going to highlight all of this right there. And you may or may not have ever seen this button node that's over here before. It's about 1, 2, 3, 4 over from your start button. That comments out multiple lines of code at once. The one next to it uncomments out multiple lines of code at once. But I want to comment all those out and tell you that all of that could have been replaced with just... Why it's doing that, I don't know. Okay. All right, something like that. And we're going to see that later on. Don't worry about the error. You'll see it later on. Okay, I'll just do this. Get rid of that. Highlight all that. And all right. So again, this is saying that when we ask for the student's ID number, we're going to get it back. Okay? And we're going to get it back as an integer. Why? Because we defined it as an integer. Make sense? This says whatever value we pass in, that is what we're going to set the ID number to. Now, we're not doing any validation of it right now, which is dumb, because the program will break if we try putting in a non-numeric value for an ID number. All right? But we're not worried about that right now. Then we do a similar type of thing for the last name. But since last name is a string, we have to return a string. Does that make sense? So that's our getter and our setter for the last name. Then GPA, or grade point average, which is a double, so that is a double, and there's a getter and there's a setter. Notice that right here, now we have code. Now we are doing some data validation right here. What are we saying? We're saying if whatever value we passed in was greater than or equal to 0, and the value we passed in was less than or equal to 4, that becomes the grade point average. Otherwise, we're just setting it to 0. Now maybe that's not fair, but that says if I don't know Matthew's GPA, it's a 0. He says, I know it's not a 0. I do too. But I'm just saying that's the way that we're setting it up. So when we create a student object in just a minute, for one of the students, we're going to give them a GPA of 4.1, purposely out of range. So what should happen is it should reset it to 0. Does that make sense? That is at least starting to show you a minimal amount of data validation inside of a class. All right? So that's everything on 370 and 371. Then on 372, the author tells you that you should put main right below this stuff. I was taught never do that. I was always taught put main in a different, put it in its own function. So I did. You'll notice, or maybe you didn't, see this at the top? Namespace OOP example. Now look at our other one, namespace, OOP example. They're part of the same project. Since they're part of the same project, how do I know that? Because the project name is OOP example. Since they're part of the same project, they're part of that project's namespace. All right, so here is our main. You may or may not recognize it or realize it right here. These two lines, those are creating two brand new student objects. Everybody see this? These are creating two brand new student objects. Then after we create them, we're setting the ID for the first student to 123, the last name for the first student to Anderson, the grade point average for the first student to 3.5. Then we're setting the ID number for the second student to 789, the last name of the second student to Daniels, and the grade point average to the second student to something illegal, 4.1. Then we're telling it, hey, display all the information. Okay? So it should really say, right here, it should say 123 Anderson 3.5, 789 Daniels, and since that's out of whack, it should say 0.0. Does that make sense? And they did some formatting here. I'm not sure why. But don't worry, it's just that 0, 1, and 2, the numbers afterwards, that's just formatting them on the page. All right, I don't know why they did it that way, but they did. So we run it. And there's our output. Exactly what I told you it would be. So we set, when we said the first student dot ID number equals 123, that called the setter. When we did the right line, that called the getter. All right? That's exactly what this program was supposed to show. Again, the only thing I didn't like about what the author did was putting everything in one file. Again, as I told you, I was always taught you never do that. All right? I don't find that acceptable, so I don't do it. So I showed you another way around it by putting them each in their own files. All right. So that was 370, 371, 372, and 373. I'm not going to say, are there any questions on that? You have to look at it to kind of be able to wrap your head around what's going on. Okay? All right. On the bottom of page 373, the author talks about more about public and private access modifiers. Okay? I told you before, it's not up here anymore, but if you remember, I gave you my 7-word definition of object-oriented programming. All right? Public methods that manipulate private data. Well, that's 6-letter words. I don't know what I said before. Okay? But you can have public data. You can have private methods. They show you here where you might have public data. Notice it's a constant. That's about the only time it's considered acceptable to have data that's public, meaning that you're going to set it and forget it, which is what constants do. So they're going to make 3 carpet objects. And each carpet object is going to have the motto at the end. Since the motto doesn't change, it can be public. Everything else is private, so that it's going to be manipulated by the getters and the setters. So there's private int length, private int width, private int area. There's the getter and the setter for length. There's the getter and the setter for width. And you notice there's a getter for area. There's no setter for area. So this is read-only. All right? Which is, when you think about it, that's, again, it's like this. I keep going back to examples because I think they're simple. Calculators are set up that if I say 8 times 9 equals, true or false, I can't change that value 72. I don't know how to do it. I can clear it, but if I could change it, now I'm saying 8 times 9 equals something other than 72. Basically, that answer in that calculator is read-only. That's exactly what area in here is. All right, there is no setter in here. Then they come in on the bottom of 375 and they create a carpet object. All right, and they show you once you run it what it would look like. Again, the model that's shown on the top of 376, that example that's right there, that model is public. All right. The other thing that you should realize, and they don't mention it in here, I said that 99.999% of the time, even more than that, data is private. They just showed you where it could be public. All right. Almost always when you work with object-oriented programming, almost always your methods are public. Sometimes, though, your methods are private. Typically, when you have private methods, they're called helper methods. So if I'm calling a public method, and that public method needs to call another method to do something, that could be a private method. All right. And if you don't understand that, I've given this example before, so I'm sure many in this room have heard this. It's like Tony owes me a favor. So I say, hey, Tony, go downstairs, get me a soda and bring it back up here. Well, Matthew owes Tony a favor. So unknown to me, Tony says to Matthew, go downstairs and get me a soda. Give it back to me when you get back. All right? And I've gone to my office. So I come back in here. Matthew has gone downstairs, got the soda, gave it to Tony. Tony has the soda and gives it to me. Matthew's a helper method. I don't need to know that Matthew got the soda. I just need to know that I got the soda from Tony. All right? That's the kind of pretty much the same way that you would use private methods. All right. Now, I'm going to say this and you may laugh, but one of the hardest things to understand in this is the word this. And it's shown on page 377 in the book. And you can kind of look at it in the following way. I was going to say you can kind of look at it like this, but people think that I'm trying to be funny. I'm not. But you don't realize when you talk about what this means, how often you use the word this. Like this is a definition of this, which sounds stupid. All right? But the word this in virtually any object-oriented programming language means the current thing that you're talking about. I don't know any other way to explain it than that. So if I'm using this to refer to an object, it's the current object. If I'm using this with a method, it's the current method. If I'm using this with a piece of data, it's that current piece of data. And that's what the author is saying in here. All right? When you start using it, it gets to be confusing when you look right here. Let me just tell you that everything that they showed here on everything this is on the bottom of page 378, everything here. The word this is not required in any of these. See that? The word this is not required. All right? You can put it in there, and many programmers do, but to me it's kind of unnecessary. All right? The word is typically used as like superfluous. You put it in even though you don't need it, so why the hell are you putting it in? But if you look on the next page, it's not on the next page. All right, I want to show you when you do need it. Okay? So I create a class. Okay, and I call the class hello. Stupid name, but you get the idea. All right, I've got int x, int y. I'm just going to keep it like that. I've got a getter, so I say public int x get return x set x equal value, and I'd have a similar thing for y. That makes sense? All right. But now I'm going to come in here, I'm going to write another method. And I'm going to call this, I don't know, say hello. And in order to say hello, I need the variable that's right here. Everybody with me? I need that variable. So I'm going to put in here int x. Now I have to say this dot x equal x. Now I have to. This variable right here, that is a copy. It's a copy. So if I were to say this, I wouldn't get an error. But what it would do, it would take whatever's in that copy, let's say it's 37. So it would say 37 equal 37. It would copy it to itself. You don't want that to happen. You want, by putting the word this here, this dot, it says take the copy, the thing that's right there, and copy it to that variable right there. All right. So if you call your formal parameter the same name as your actual parameter, you must use the word this. You must do that. So how do you get around that? I can call it A, right? Then I can either say this dot x equal A, or I can just say x equal A. So the way to get around it, if you don't want to use the word this in the particular context right here, if you don't want to, just don't call your formal parameter the same thing that you're calling your actual parameter. All right, that's the easiest way to get around that. There are times when you'll want to use the word this, and I think that'll become more obvious, hopefully, after we go through Chapter 10 next week. Like I said, when I give this lecture, and I know I got to do it for basically every class, you know, and I look around, most of you have the same look on your faces. The God, please come take me now look. All right? And I get it. I had to sit through the same stuff when I learned it. All right? And it doesn't, with most people at least, it doesn't sink in right away. And even if it does, it's like, okay, I even sort of get this. I still don't have a clue as to why the hell we're doing it. All right? So, on the bottom of page 380, very bottom of the page, they talk about a constructor. All right? Now, the big thing about a constructor is if you look right here, you look at what's in blue. A constructor is a method, but it's a special method that gets called when you create an object. Okay? Now, I don't even want to show you this yet. If I do this, if I create a class, like I just showed you, that class hello, all that other stuff I showed you. If I come in there and I say hello H equals new hello. Because I use the word new in there, that means a constructor is going to be called. If you don't write a constructor, if you don't write one, the system writes one for you. All right? And it would look just exactly like this. Public, hello, paren, open curly brace, close curly brace, which means it wouldn't do a frickin' thing. But it needs a constructor. That's just the way that all languages work, whether it's this language, Java, or whatever. All right? But what you typically do in an object-oriented programming is you write your own constructor. You write your own constructor. You can also overload. We know what that means now. You can overload a constructor. You're going to see that in just a minute. All right. This constructor, even if you don't write it, what does it do? Take a look at what it does right here. It takes any numeric fields that you've created and it automatically sets them to 0. Whether you do it or not, it does it for you. It takes any character fields and it sets it to \0, which is a null character. It takes any Boolean field and it sets it to false. It takes any string field and it sets it to the empty string. Double quote, double quote. It does all that stuff for you. So in other words, it sets default values for your object. That's where you initialize your object. Not when you create the instance variables, but in the constructor. All right? If you do your next test and any of you create instance variables, like we just looked at before with a grade program, the last name, the ID number, and the grade point average, if any of you, when you declare those variables, if you initialize them, I take off. You should only initialize them in the constructor. The constructor is a special method that gets called when you create an object. You can pass stuff to a constructor. Here, this is when you look at this. It says class employee. Then this is the constructor, public employee paren. If there's nothing in those parens, it's called either a parameterless constructor or a no-arg constructor, because there are no arguments. All right? But sometimes you want to be able to call this and you want to be able to pass arguments. There is an example. So if you created an object based on this, you'd have to pass a double in when you created the object. You're going to see this because come, 2, 4, 6, about 8 or so pages, we're going to go over the second example. And in that second example, we're going to create constructors. All right? And I just mentioned you can overload constructors, so you can have 2 of them. Please look up on the screen. Here we have what? 1, 2, 3, 4 different constructors. You know this from before that each one of them has a different value in the parens, correct? One has nothing, one has an int and a double, and one has a char. You may or may not have noticed this, but a constructor is a special kind of function. You cannot have a return type. You see how with all those constructors, it doesn't say public void. You can't even make it void. No return type in a constructor. So this constructor would be if you created an object and passed it nothing. Here you'd create an object and you'd pass it an integer for the ID number. Here you would create an employee object and you'd pass it in an integer for the ID number and a double for the salary. And here you'd be creating an employee and you'd pass it in a character for some kind of code. All right. So they show examples of creating each one of these different kinds of objects here on page 384. And once you do that, boom, there it is. This is the only one right here that we created where we passed it in a salary. That's why the other 2 just defaulted to 0. All right. On pages 385 and 386, they talk about using something that's called a Constructor Initializer. Now, I wouldn't have brought this up here, but the author did. Okay? When I did this, it didn't work. It didn't like that colon that was in there. In fact, I'm going to show you. I already showed you the first program. Let me bring up the second one for you. I don't know if this is it or not. Oh, that's the... So do I have 2 copies of the same program open? Nope, that's number 3. So let me grab this one. And we're going to close this. And we're going to open up the next one that the author goes over with you. All right, so project solution. Number 2. All right, let me run it and then we'll go back and take a look at it. Okay, now we have 4 students. The same 2 we had to begin with. The same 2, and we've added 2 more. The third one that we added is valid. Their ID is 456. Their last name is Marco. Their GPA is 2.4. That's valid. The last one we created is a brand new one with nothing in it. So the default ID number is 0. The default last name is XXX. And the default GPA is 0.0. Okay, so how did we do that? Let's take a look. If I come into here, what you notice is what was added was the code right here. Those are constructors. All right, so we've got a constructor that has nothing in it, a parameterless constructor. Now the author says that they want you to do this. All right, but notice what happens when I do that. See how I get the red tick underneath the colon? It doesn't like that. It gives me an error message for that. It says invalid, colon in there. It doesn't like it. But if I take it out and do it the old-fashioned way, which is like this, now it has no problem whatsoever. I'll see if I can hunt that error down and tell you what the problem is or was. So in English, what this says is I can create a student object and pass in a number that represents their ID. I can pass in a name that represents their last name, and I can pass in a double which represents their grade point average. All right? Or I can pass in nothing, and if I do that, I set their ID number to 0, I set their last name to XXX, and I set their grade point average. Okay? So if we go back to this program, the only thing that's changed in here was we added 2 more students. Now, after we added the first student and the second student, after we added them, but before we printed them out, we gave them values. You saw that in the last program. All right? But now with these new guys, Marco and, blank, all right, since we didn't give them anything, with the blank, the fourth one, we didn't give them anything, this automatically takes 4, 5, 6 and assigns it to the ID, it assigns Marco to the last name, and it assigns 2.4 to the GPA. So this results in us calling this. All right? And this one right here, since we're calling the parameterless constructor, that ends up calling this. All right? And that's exactly what the author is showing you, all right, in the book here. On the You Do It that's on pages 387, 3 and 388. All right? The only other thing I want to mention as far as what's in there is the author talks about on the top of page 386, in a constructor, you can make something read-only. But notice that when you do that, that's not like we did before where you have a get and a set, but it's literally if you put in there read-only. If you have the word read-only in there, you never should put in a setter. It makes no sense to do that. You'll get an error message. All right? So you can just leave it off, or you can leave it off and tell the system that it's read-only. All right, that's what the author is doing right there. Let's go over this next section, then we'll take another break. Like I said, just telling you, this stuff is about as dry as it gets. All right? So next, starting on the bottom of page 388, they talk about what are referred to as object initializers. All right? If you use an object initializer, you can use it either one of these ways. These two things do exactly the same thing. So if you want to create an object, all right, and basically you want to initialize it on the fly as opposed to letting the constructor do it, you can do it this way. Now, you might look at it and go, okay, whatever. Why the hell did you just teach us something and then say you can do it this way? This is an optional way of doing something. This is not exactly the recommended way of doing it. And I would say when you're first learning it, I would never use these object initializers. Right? So I would never test you and say, hey, even though I told you never to use them, well, on the test you have to. I'm not going to do that. Read through the section, and if you're like, well, that makes sense, then use it. And if it doesn't make sense, then don't use it. That's all I can tell you. All right, I guess we will go just a little further. That is, let's just talk about what's on, starting on 392, and it's on what's called overloading operators. Now, I'm going to show you something. This shouldn't be a big thing to you. If I do this, int x equals 7, int y equal 10, int z equals x plus y, string fname equals Jeff, string lname equals Scott, string, I don't know, all, dumb name, but equals fname plus a space plus lname. That's all valid code. All right. On line 6, true or false. On line 6, the plus sign means addition. True or false? Not a trick question. I'm sorry, not line 6. On line 3. Does that mean addition? True? I would say so. All right. On line 7, it doesn't mean addition. It means concatenation. The plus sign is an overloaded operator. It can do two different things based on the context in which you're using it. The system is smart enough to know if it's numbers, add them. If it's strings, concatenate or combine them. You can say, well, that is an add, sort of, but it's really not. All right? So the plus sign in a programming language, and really in any programming language, is an overloaded operator. And there are several operators that you can overload. Here's the list. Why do you want to overload something? To make it do something it wouldn't otherwise be able to do. Now, the example that they give in here, either depending on your point of view, it's either a really good example or it stinks. All right? They're working with a book class. And they say when you get an author who has 2 books that she or he has written, we want to combine those authors together. All right? So we want to give it a new title. Okay, so if we had one book that was called Hello World and the other one that was called Goodbye World, then the new title would be Hello World and Goodbye World. Does that make sense? All right. The number of pages. So let's say that in Hello World there were 200 pages and in Goodbye World there were 100 pages. So the combination would be 200 plus 100 or 300 pages. All right. And the third one there, for the price of it, let's say that they were both 25 bucks. All right, then the first one would be 25, but the second one would only be 10. What we're doing in order to be able to do that is we are overloading, and they show it right here on page 394. We are overloading the plus operator. We are telling it that what we want it to do is, in essence, add those fields together that I just told you about, or concatenate them together. All right? I believe I could be totally wrong with what I'm about to say or totally right. I think you're all intelligent people in here. All right? That said, I think there's only so much I can jam down your throat at any one time where it totally makes sense. This is an advanced topic. It's mentioned right here. The author actually does a good job on 392, 393, 394, 395, 396, and the top of 397 of explaining it and giving you an example. That's all I'm giving you. I would not test you on this. My counterpart in St. Louis, Paul, he believes that the hardest stuff that's like this, by and large, he teaches them everything, and that's usually what he tests them on, is the hardest stuff. Now, maybe he ends up making them better programmers than I make you. I don't know. But to me, I want you to understand the fundamentals. Because to me, unless you've got an understanding of the fundamentals, again, it's like the old adage that I don't teach you how to swim by when you come in there the first day, me taking you down to the deep end and pushing you in. To me, that very few people are going to learn to swim that way, and a lot more are going to drown. And I don't want you to drown. All right, we're up to 397. We only have about 10 or so pages left. Let's take another break, and let's come back, please. Let's make it 10:15, and then we'll finish this up.